All right, everybody. So, basic answers to questions 1 through 3. By the way, this is focusing on the season's Regents review. All right. And so we're going to start off with number 1. Base your answers to questions 1 and 3 on the diagram below on your knowledge of Earth science. The diagram represents the apparent path of the sun through the sky as viewed by an observer in the northern hemisphere. Points A, B, C, and D represents 4 positions of the sun. So number 1, what is the approximate time of day when the sun is at position C? All right. So there's one thing that we have to remember. All right. When the sun is at its highest point right here, right? What is the solar time when the sun is at its highest point? When the sun is at the highest point, we consider that to be solar noon. When the sun is at its highest point, we consider that to be solar noon, right? Otherwise, around 12 p.m. So now I know that at this point, it's 12 p.m. Keep in mind that the sun rises somewhere on the east, right? Sun rises somewhere on the east side, right? Sometimes it could be in the northeast side, it could be directly east, sometimes it could be southeast. And we know that the sun sets somewhere on the western side, right? So I know that for a fact that everything below B is going to be before 12 p.m. Everything after B is going to be 12 p.m. So when I'm looking at C, C is closer to solar noon than it is towards sunset. And so that's the reason why the best answer is going to be choice B, 3 p.m. If it's 12 p.m. here, I know that C is a few hours later where the sun will be after B. That's why 3 p.m. is going to be the best answer. Number 2. Number 2 says, this apparent path of the sun through the sky is caused by. So why is it that we see the sun rising and setting, right, in these different positions? Why is it that the sun's apparent path, right? Why are we able to see the suns at different positions throughout the day? Key word, throughout the day. This movement of the sun, this is all happening in one day. It's all happening in one day. So that lets me know what else occurs in one full day? The Earth's rotation. So the reason why the apparent path, right? Meaning that this is how the sun looks like it's moving throughout the sky. Not in reality, but this is how it looks like it's moving through the sky. It's because of the Earth's rotation on its axis, not the sun's revolution, not the Earth's revolutions, and not the sun's rotation. It's all about the Earth's rotation on its axis. All right, number 3. Number 3 says the observer has the longest shadow when the sun is at position what? Well, here's something that we have to remember. The higher the sun's altitude, the shorter or smaller the shadow. All right. The lower the sun's altitude, the longer or larger the shadow, the observer's shadow. All right. So when the sun's altitude is high, the shadow is going to be small. When the sun's altitude is low, the shadow is going to be large. So if we need the longest shadow, We need a position where the sun is at the lowest point. Where is the sun at the lowest point? The sun is at the lowest point right here at D, which means you're going to get the longest shadow. All right. When the sun's at the highest point, you get a very small shadow. When the sun's at the lowest point, you're going to get the longest shadow. That's why it's going to, I don't know why the numbers are mixed up, but it's choice, right? Letter, position D, which is choice C. Position D is the correct answer. All right. Number 4 says the graph below shows the general relationship between latitude and the duration of insolation on a particular day of the year. All right. And it gives us the chart of duration of insolation, sorry, the graph and the latitude. Which date is represented by the graph? When I'm looking at this graph, here's what I know first and foremost that we need to know right off the bat. The duration of insolation is equal to the amount of daylight hours. All right, that's something that we have to, oops, sorry, that we have to remember. I'm gonna move it so that way we can see it right here. All right. So the duration of insolation is talking about the amount of daylight hours. And what's interesting that I see at this point right here, right? We get more than 12 hours of daylight the moment that we are at latitudes above 66.5, I'm sorry, above the equator, right? That's where we're getting the most amount of daylight hours. And as a matter of fact, we get 24 hours of daylight at latitude 66.5 degrees north, which is also known as the Arctic Circle, right? When I'm looking in my notes, looking in my season notes, oh, there we go. All right, here we go, right here. When I'm looking at my season notes, I notice that right here, that the latitudes, once you get to the equator, so I'm looking at the Tropic of Cancer, right? Even the Arctic Circle. Once you go above the equator, it looks like more and more daylight hours is being exposed above the equator. And what does this happen? This happens during June 21st. And it makes sense. Why does it make sense? Because think about it. We know that what season do we get the most amount of daylight hours, right? During the summer. And if you're located above the equator, you're going to get more daylight hours during the summer. And you're going to get less daylight hours during when? The winter, right? And so that's the reason why the correct answer is June 21st, because that is when we're going to get the most amount of daylight hours during the summer solstice. So all locations that is above the equator, right? This is all on the north side of the world. And look, we're all getting more than 12 hours of daylight during this day. All right, which is the first day of summer. That is the reason why it is choice B. And we know during the summer solstice, the southern hemisphere gets the least amount of daylight hours, right? Because the seasons are switched between the northern and southern hemisphere. All right, number 5. We're going to be focusing on number 5. So number 5 says, the model below shows the apparent path of the sun as seen by an observer in New York State on the first day of one of the 4 seasons. All right. And it says, this apparent path of the sun was observed on the first day of what? Now, this is how, when you get a problem like this is how we can tell the first day of what season is it occurring. You have to look at the path of the sun. All right. And more importantly, we have to look at where the sun rises, right? The sun rises right here. and where the sun sets. The sun is setting right here, right? Now I see that the sun rises between south and east, right? So that means the sun is rising southeast. And the sun is setting between south and west, southwest. So sunrise is occurring southeast and sunset is occurring southwest. On which day does that happen? When we look at our notes, and this is something that you have to memorize, all right? When we look at our notes, the sun rises and the sun sets right here, right? During the sun rises southeast and sets southwest on December 21st, the winter solstice, right? Even if you look at this diagram right here, right? The sun rises southeast, sets between south and west, and it occurs December 21st, the winter solstice. We also know that the winter solstice also represents, there we go, the first day of what? Winter. So the correct answer is winter. And you have to memorize on your note sheet. You have to memorize where the sun is setting and rising to be able to tell what day it is on the year. All right, so you can make sure to look at that note sheet. All right, number six. Number six says the table below shows the duration of insolation hours of daylight measured by four observers, W, X, Y, and Z, at four different latitudes on both March 21st and June 21st. There were clear skies at all four latitudes on both days. Which observer was located at the equator? So there's something special about the equator. And the reason why that's special about the equator is the amount of duration of insolation, right? Duration of insolation, as we learned before, all that is the amount of daylight hours. So remember to say that to you again. Duration of insolation talks about the amount of daylight hours there are during the day. All right. So in the notes, there was a chart that I gave you. And in this chart, it basically shows you for every latitude, I've also given you the duration of insolation, right? And I've given it to you for the equinoxes, the winter solstice, and the summer solstice. Look what happens when I scroll to the equator, right? And so the latitude is for the equator 0 degrees. Look at the amount of daylight hours at the equator for each day. During the summer solstice, 12 hours. During the equinox, 12 hours. During the winter solstice, 12 hours. So what do I know about the equator that's so special? For every day in the year, there are generally about 12 hours of daylight at the equator only. And so that's important because when I'm looking at the chart, there's only one observer that is experiencing 12 hours of daylight in both days. And it is observer X, which is choice D. And once again, that's what's special about the equator. Every day for the year, you're generally on average is getting about 12 hours of daylight. All right, so it says positions 1, 2, and 3 in the diagram below represent the noon sun above the horizon on 3 different days during the year, as viewed from Binghamton, New York. And it says, at which position was the noon sun on January 21st, as viewed from Binghamton? All right. So there's some notes for us to take when looking at this position, when looking at this chart, that we just got to remember in general. All right. So let's start breaking down some of these notes, all right? So June 21st, which is the summer solstice, right? In New York, that's going to be where the sun is at the highest altitude. That date is the sun's highest altitude, June 21st. That means that the sun will never go higher than at position 1. All right, that's what makes the summer solstice so special. That's when you're going to get the most amount of daylight hours. That's where you're going to get the most amount of intensity that comes from the sun. And position 3 will be the sun's lowest altitude throughout the entire year. All right, so the sun will never get any lower. The other thing we have to remember is that September 23 is an equinox date, right? Isn't there another equinox date besides September 23? It is also the same position as March, right? And let's say 21st, 22nd, or even 23rd. All right. That is something that is keep in mind, right? The equinox has two dates. It's the first day of spring and the first day of fall. Now, why is that important? Because now we get to explore. Now we get to explore. Where's January 21st? Where is the sun going to be? Well, we just said the sun's highest altitude will be at position 1. The sun's lowest altitude will be at position 3. So guess what we can cross out right off the bat? Of these choices, we can cross right off the bat A and B. The sun will never be above position 1. The sun will never be below position 3. Now, I got to look at the cycle that takes place, right? So if June is here, let me zoom in even more. If June is here at position 1, right? The sun will be here in July, right? The sun will be here in July, and then it'll be here in August, right? And then the sun will be here in September. Then after that, the sun will be here in October, right? We're getting less daylight. The sun will be at this position in November. Well, I know it's not the best. That's November. And then the sun will be here in December. So where is the sun going to be in January? Remember, December 21st is where the sun is at its lowest point. So at that point, now it goes back up again. So that means the sun will be here in January, right? Let me just make sure to write it clear. It'll be at this point in February. And we said position 2 is where March 21st is going to be. Then it goes to April, and then May, and the highest is in June again. And the cycle repeats itself over and over again. It repeats itself over and over again. So where is the sun in January? Right here, right? Between position 2 and 3. And that is going to be choice C. All right, number 8. So number 8 says, base your answer to the following question on the diagram below, which represents the position of the sun with respect to Earth's surface at solar noon on certain dates. The latitudes of 6 locations on the same line of longitude are shown. The observer is located at 42 degrees north in New York State. The date for the sun at position A has been deliberately left blank. All right. And so I'm looking The question says, when the sun is at position A, which latitude receives the most direct rays from the sun? So this person is at 42 degrees north in New York State, right? When the sun has the highest solar noon on June 21st, right? And it has the lowest solar noon on which date? Do you remember? December 21st. What is the name of this date? Otherwise known as the winter solstice. All right, otherwise known as the winter solstice. All right. Now, what's interesting about the winter solstice is that there is a latitude that receives the most direct rays of the sun during the winter solstice. Which latitude is that? Right? Now, when we say direct rays, we're saying that the sun is at a 90-degree angle from an observer at solar noon, right? 90-degree angle at this latitude, right? But we don't know what this latitude is. That's what we're going to find out. When we look at our notes, right, we know A is at the winter solstice. So let's look at our notes and let's look at the winter solstice. All right. And what do I know about the winter solstice? Here we go. And guess what? Right here, the winter solstice about December 21st, December 22nd, when the North Pole axis tilt points away from the sun, right? And it says the sun forms a 90-degree angle at noon at the latitude 23.5 degrees south, right? This 90-degree angle, we call it, right? We call it a direct sun ray. That is a direct sun ray when it's giving a 90-degree angle directly overhead, right, at an observer. So the latitude is 23.5 degrees south. All right. So that means if we go to our reference tables, let's go to our reference tables real quick. And let's scoot over to page 4. All right. Scoot over to page 4. And we see the latitude right here, right? 23.5 degrees south, right? So you don't have to worry about memorizing what is the Tropic of Cancer, what's the Tropic of Capricorn, because page 4 of the reference tables actually tells you. So this entire latitude right here, if you're located anywhere on this line, right? Anywhere on this line in the world, during the winter solstice, at solar noon, you're going to get 90-degree sun rays. You're going to get direct sun rays at this latitude. So if you're located anywhere on this red line, at 12 p.m., solar noon, the sun will be 90 degrees over your head. All right? And so the correct answer is the Tropic of Capricorn, choice C. Number 9. Number 9 says, base your answer to the following questions on the diagram below and on your knowledge of earth science. The diagram labeled A, B, and C represent equal size portions of the sun rays striking Earth's surface at 23.5 degrees north latitude at noon at 3 different times of the year. The angle at which the sun rays hit Earth's surface and the relative areas of Earth's surface receiving the rays at the 3 different angles of insolation are shown. All right. So they're giving us the different angles that the sun is hitting at this latitude, 23.5 degrees north. So it says, as viewed in sequence, there we go. Oops. As viewed in sequence from A to B to C, these diagrams represent which months and which change its intensity, the intensity of insolation. All right. So one thing we have to remember is that the higher the sun's altitude, the higher the sun's altitude, the greater the intensity of insolation. All right. That means that when the sun is at its highest angle, you're going to get the greatest amount of intensity of insolation, right? And insolation, all insolation is just energy that comes from the sun, right? So that's one of the reasons why, right, the equator is just so hot. It's because it's receiving the greatest amount of insolation from the sun. All right. So now that I know the relationship, I know that when it's at A, I get the greatest intensity, right? I get the greatest intensity at A, and at intensity, and at C, I get the lowest intensity of insolation from the sun. Okay? Because I'm in the latitude 23.5 degrees north, okay? Because I'm at 23.5 degrees north, where do I get that from? It tells you right here, the location. All right, you're at 23.5 degrees north. That lets me know that during the summertime, right, I know I'm going to get the greatest intensity because that's when the sun is the highest. And I know during the winter time, I'm going to get the lowest intensity. And so, which option shows that during the summer, I get the greatest intensity, and during the winter time, I get the least intensity? And it's going to be choice B. All right. So we did it in order. You're getting the greatest intensity, right? This represents June. At B, it's somewhere in the middle, which is September. And at December, the sun's at the lowest altitude, which means you're going to get the least amount of intensity. Now, keep in mind, this all occurs at 23.5 degrees north. And if we go to our reference tables, right, 23.5 degrees north is located right here. And that means you're located above the equator. So because you're located above the equator, right, it makes sense during the summer that you're going to get the greatest amount of intensity from the sun, right? That's the reason why it's warmer above the equator during the summertime. And so that's why the correct answer is B. All right, number 10. Number 10 says, base your answer to the following questions on diagram below. In our knowledge of Earth science, the diagram represents the apparent path of the sun across the sky at a New York State location on June 21st. Point A represents the position of the noon sun. Points A and B are on the path are 45 degrees apart from each other. Which diagram represents the correct position of Polaris as viewed from New York State location on a clear night? So once again, Polaris is the North Star, right? And we know that there is a special relationship between Polaris, the altitude of Polaris, and your latitude, right? The altitude of Polaris is equal to your latitude. The other thing that we know is Polaris is viewed on the northern part of the world. So that means that you want to be facing towards the north side, right, to see Polaris. That's going to help us out. All right. So, what do I know about New York State? Do I know anything about the latitude of New York State in general? Yes, I do. If you ever forget where the latitudes of New York State, if you ever forget where the latitudes of New York State are, go to page 3 of the reference tables, right? And the entire state has latitudes between 40, right? Between 42 all the way to about, I got cut off a little bit, so I want to make sure I get everything. All right. So 40, 41, 42, 43, 44, 45. So the entire state is somewhere between 40 degrees north to 45 degrees north. Why is that important? Because we just said right here, the altitude of Polaris is equal to your latitude. That means that Polaris is going to be at an angle between 40 to 45 degrees. That's the angle that Polaris is going to be at. All right. So now when I go back to my problem, I'm looking for Polaris, and Polaris has to be at an angle between 40 to 45 degrees because you're at New York, and New York has a latitude of 40 to 45 degrees north. So will Polaris be at A? Nope, because that shows me 90-degree angle. And New York is not at 90 degrees north. So that's why it can't be A. Can it be B? It can't. You know why? Because you're viewing Polaris on the south side. You're supposed to view Polaris somewhere on the north side. All right. And if we take a look, we'll keep going. Sorry. All right. When I look at C, they're telling me Polaris is right on the horizon, right? That means that Polaris has an angle of 0. That means that C means this person's at the equator because it has a latitude of 0 degrees. We need to find where the person is at in New York. And that's why the correct answer is, erase this stuff. All right. That's why the correct answer is going to be D, because look, Polaris looks like it's halfway, right? Somewhere between 40 to 45 degree angle, right? It looks to be more like 45 degrees, looks about halfway, 45-degree angle. That means this person must be somewhere around 45 degrees north, and it checks our boxes because New York is somewhere between 40 to 45 degrees north and is being viewed on the northern part of the sky. That's why the correct answer is D. All right, number 11 says, base your answer to the following question on the diagram below, which represents 4 stations A, B, C, and D in a laboratory investigation in which equal volumes of sand at the same starting same starting temperature were heated by identical light sources. The light sources were the same distance from each station, but at different angles to the surface. 2 thermometers were used at each station, one just above the surface and the other just below the surface. The lights were turned on for 30 minutes and then removed for the next 30 minutes. Temperatures were recorded each minute for the 60 minutes. And the question says, which station received the least intense light energy? Remember that we said the intensity of light, right, has a direct relationship, between the altitude of the light source. What does that mean in general? The lower the angle, the lower the intensity of light energy. All right. The lower lower the angle of the light source is equal to the lower the intensity of the light energy. All right. So because I'm looking for, if I need to find which one has the least intensity light energy, I'm looking for the light source that has the lowest altitude, the lowest angle. And the one that has the lowest angle is station D. Station D has the lowest angle between all of them. So that means it has the least light energy. All right, number 12. Number 12 says the diagram below represents the horizon. Oops, there you go. And the sun's apparent path, A, B, and C, on 3 different dates as viewed from the same location in New York State. So this is in New York State. Which table correctly shows the dates on which the apparent paths of the sun were observed? So I already know. If I'm in New York, right? I'm in New York. If I'm in New York, when the sun has the highest and longest path, I know that this is the first day of summer. First day of summer. All right? That's where A is. That's why we have longer daylight hours during the summer, right? The sun has a longer path, right? And that's when it reaches its highest altitude throughout the year at solar noon. And I know C, when the sun has the shortest and lowest path, right? I know that it is the first day of winter, right? And I know, since I know the first day of winter is December, right? Let's say December 21st. The first day of summer is June 21st, right? B is in between. So B can be March 21st, which is the equinox, right? Or September 21st, which also represents the equinox day. Knowing what I know, which choice tells me A is the first day of summer because it has the highest path, right? C is the first day of winter because C has the lowest path of the sun, and B is in between, which could be March or September. And when I look, the one that has that option is choice D. Is choice D. Positions 1, 2, and 3 in the diagram below represent the noon sun, 13, above the horizon on 3 different days during the year as viewed from Binghamton, New York. And A, which day of the year would Binghamton, New York receive its highest intensity of insolation? Remember, and I said this throughout the video today, I'm going to say it again, right? The higher the sun's altitude, right? The higher the intensity of insolation. Okay? So, which day would you get the highest intensity insolation? It has to be the same day that you get the highest altitude from the sun. And so that day is going to be June 21st in New York. June 21st is my answer. Which day of the year? Or if you were to say the summer solstice, that's fine as well too. But yeah, the day of the year is June 21st. When I'm looking at B, right? Which day of the year would receive the lowest intensity? That means it has to be the day of the year where the sun's altitude is the lowest, and it is December 21st. All right, which makes sense, right? It's very cold for us during December. Why? We're not getting as much energy from the sun because the altitude of the sun is lower, which means that the strength or the intensity of the insolation is less. All right, that is all for this worksheet, right? Yes, there it is. It's all for this worksheet. All right, please make sure to like, share, and subscribe. New videos coming on the way. Have a wonderful, blessed day, and until next time, peace.